This video, entitled Exploring Models 4, addresses signal flow, propagation, and dependencies. For this video, we have already loaded the multiplexer modulator example model. By quickly glancing at the context-sensitive panel below the drawing, we notice that there is a very brief description telling us a little about this design, including a note that the multiplexer has 4 object states, and that the design is hierarchical. Other design configuration details can also be tracked in this panel as well. Referring back to our example model drawing, we should observe that inputs are typically placed along the left side of the model, and the outputs along the right side. These input I/O flags along the left side of our example model represent the input of functions, data, or signals coming into the model. These signals propagate across the nets, through the objects, and eventually propagate to an output. The path of signals is determined by dependencies within each object. For example, if this particular model had multiple outputs on the right side, they may have different paths from one input to the output. These paths are determined by dependencies that are set within each object, as well as states which may represent operational modes or testing modes of the equipment or system. To examine one of these input I/O flags, we'll click on the object and see that it has a single port on it. When we select the port, we can then choose the output functions from the context-sensitive panel below. We see that it has a source1 function name. In this case, it was just a default name given to this output function based on the object name. This source1 function propagates to the net. When we look at the net, we can see that the source1 function is in fact there. As we look at other nets within the model, we can also examine their functions. This net, for example, has been identified as modulator 2, modulator output, which indicates that the function comes from the modulator 2 object. That function then propagates through the multiplexer as established by the dependencies within the multiplexer. By selecting the multiplexer and then its only output port, we are able to identify all the output functions associated with that port by simply opening the Output Functions tab on the bottom panel. This example describes the multiplexer output to only be dependent upon the modulator 2 input into the channel select. The remaining channel select modulator input functions are described in the Non-Dependencies panel. To edit or to add any other dependencies to the modulator 2 output, simply select the input function from this listing and select the arrow button, which will add this new input function to the Input Dependencies area. Another common way to move the input functions between the Non-Dependencies panel and the Dependencies panel is to double-click on the input function. Notice that the possible input functions are represented with the color green and will appear anytime an output function is attempting to list any available object input functions. Effectively, we can edit the output function dependencies so that the multiplexer can be dependent upon any of the modulator channel select inputs. In contrast, when we select modulator 2 and then select its output port, we can observe that the output function mod2 is boxed in a brown highlight, meaning that the modulator 2 object is a hierarchical object that is linked to a lower level design. In such case, these dependencies are not able to be modified at this level, and any modification to the dependencies of Mod 2 must be performed at the lower level of design hierarchy. Additionally, the dependencies for Mod 2 are grayed out to prevent any disassociation to the lower level design. Moving back to the multiplexer once again, we can observe that the output function of the multiplexer adjusts to the selected internal net dependencies, which in turn adjusts the output function to the net between the multiplexer and the equalizer. This enables the desired multiplexer output function to propagate through the equalizer to the amp, since the equalizer only has a single input and a single output. So there are really no other options for this function to travel other than directly through that object. We can look at the net from the equalizer and see that the multiplexer output function was carried through the equalizer object within our model. This is essentially how all the functions propagate through a model through these dependencies. This differs from drawing tools like Visio or PowerPoint or other CAD or CAD-like drawing applications that produce strictly static drawings of objects, but are not intended to define any relationship between the objects. Express actually establishes relationships between objects throughout highly complex system models, simply based on those dependencies and how the signals propagate through the objects and models that fully describe the system. Another feature within Express that determines the signal path at a particular point in time is the state feature. With the state feature, we can construct tests which are associated with functions for a particular point in time. Within this example model, we have established tests for when modulators 1 through 4 are active. Moving our attention back to the navigation tree, we can observe how neatly the tests for these states are packaged in the test sets folder. By clicking on this folder, we will select the design state tests that will contain the tests that are enabled when that specific state of the design is being analyzed. When the design state 4 path-based inspection test is selected from this tree, we can follow the propagation of the source 4 input as it provides a signal through the modulator, equalizer, amplifier, and video out. This provides us a way to develop and communicate the testing of that path within this design. In summary, it is the input flag which provide the input signals into our design. From those input signals, dependencies are established within the objects, which then determine the path for the signal flow, which eventually terminates at the output. States can also help us to determine signal path and signal flow for particular points in time. This is extremely useful to represent various operational modes or test modes within our design. This concludes this video tutorial introducing signal flow, propagation, and dependencies.